Hey, welcome back. You had a long holiday weekend. No doubt just sitting at your house again. But I hope it was relaxing. I just wanted to launch you into our lesson today just by telling you instead of writing it all down. Today we are going to begin talking about slope. Last week we spoke about linear equations. We also graphed linear equations. A lot of you guys, you emailed me questions, you reached out, which I'm grateful. Hopefully I could help you. Remember, I did post all the answers to last week's work in our Google Classroom, so if you haven't taken a peek at that, take a peek. I know last week was brand new. It was somewhat of a challenge. You know, it was our first official week of distance learning where I was sending you out work and expecting you to turn some stuff in. So again, don't hesitate to reach out. But this week we're talking about slope. Slope is something we really need to know moving forward in algebra. When you study lines, slope is essentially the steepness of a line. How steep is the line? Is the line like this? Think about a roller coaster. Is the roller coaster going straight down like this? Is it kind of like this? You know, it's something we have to discover in this this journey we're on right now. So today we're going to dip our toes into the concept of slope, and we're going to finish that throughout the week. And then next week we'll hopefully finish it off and tie a nice little bow around it, and you guys should be masters at slope. So let's do this. Alright guys, like I just mentioned, we are going to take a peek at what slope is. Guys, slope is simply the steepness of a line. Okay? And when we look at the steepness of a line, I'm going to draw this super quick diagram. Imagine we have the y-axis and the x-axis. Here's our coordinate plane, something you guys are all used to seeing. Now, if I have a line like this going straight through, the steepness of this line is constant throughout. Okay, it is consistent. Last week we just spoke about linear equations, so this would be a linear equation. It's a straight line, but this specific line has the same steepness throughout. It is going in one direction and it is not changing. Now, the steepness of a line is when we're going to compare two different things. Now remember, this is the x-axis and this is the y-axis. The steepness of a line is comparing the change in y to the change in x. Guys, essentially that's your ratio. You're comparing the change in y to the change in x. Okay, we've talked about ratios before. We typically write them in fraction form, but the change in y, so if I start here and I want to go here, the change in y is from here to here. That is the change. You look at the numbers here, and then the change in x is the horizontal. It's from here to here. So I put something here in x, now I put something here in x. That is my change from y to x. And we're going to get in specific examples in a second, but you may remember this as rise over run. That is how we typically see slope. I will go nice and easy throughout this concept. It is very important that you do learn this, especially moving forward in algebra. And let's take a peek at a few examples. I'm going to give you a few, and then I'm going to have a few for you to do on your own. So here we go. Okay, here's an example I had lying around. What we're going to do is we're just going to take a peek at this line right here. Okay, now obviously we can see it's a straight line, so it is linear. I'm going to label my x-axis and y-axis. At this moment, I don't care so much about the labels or anything like that. I just want you to see what the slope of a line is, okay? Now, the slope of a line is, we want to focus, can't even talk, we want to focus, I think that's the name of the kid in Christmas Story, Farkas, the mean kid. We want to focus on the actual points that we graphed here. So we have our ordered pairs and someone plotted these points on this graph. So we're going to look at this point, this point, this point. So we're going to go from point to point. So I talked about that slope is the change in y over the change in x. In other words, it's the rise over run. Guys, it's the ratio, rise over run, change in y over x. So I'm going to start here, and I'm going to go up to the next point. So how far do I have to go up from this point to get up at the same level as this point? Well, guys, I'm going to go up to here. Now, I know that I went up 2 squares, but I'm not worried about the squares, guys. I'm worried about the digits over here. So I went from 5 to 10. So how far did I go up? I went up 5. Do you understand? I went from 5 to 10. From here to here. That is an increase in 5. Okay? Now next, I have to go horizontal. I got to do the run. I have to do the X. Now I'm going to go from here to here. Well, I just went from 10 to 20. From 10 to 20. What is that an increase of? Well, that's an increase of 10. So my Y increase, or my Y change, was 5. My X change was 10. So here's my ratio, 5 over 10. Well, guys, it definitely, if you're in my class, you should always know anything written in fraction form, we can simplify. So let's go ahead and simplify 5 over 10, and that simplifies to 1 over 2, or 1/2. Well, guys, 1 over 2, or 1/2, guys, that is your slope. Now, you're done. It's that simple. However, if you're still confused, like, well, I don't get it, I don't understand. I know how you got 5, I know how you got 10, I know how we simplified it to 1/2, but what does that mean, slope? What does that mean? Remember, slope is the change in y over the change in x. So if I look at it from this standpoint, every time I go up 1 on y, I'm going to go over 2 on x. Up 1 on y, over 2. Up 1 on y, over 2. Up 1 on y, over 2. So on and so forth. And then when we connect those points, that's going to make our line. You're going to see that in a moment. I just wanted us to take a peek at this. I wanted to see just a handful of examples. Okay? Now, the next thing is we're going to graph our ordered pairs, and we're going to see what this change is. Okay? So here we go. Okay. So this little example I have up here, I have our graph. And you know what is not labeled? Our x-axis and our y, for those that continuously kind of forget about that. And I put together this little chart right here. So here's the x-axis, here's the y-axis, and the x, we're speaking to yards, okay? So 1 yard, 2 yard, 3 yards, 4 yards. And on the y-axis, we are talking about feet. So there's 3 feet, 6 feet, 9 feet, 12 feet. So let's go ahead and graph these. This is my first ordered pair, okay? X is 1, Y is 3. So I'm going to go over X and then 3. Remember, I'm not going up 3 boxes. I'm going up to the 3 that is on the Y axis. Next, I go over 2, up 6. I'm going to go over to the 2, up to the 6. Next, over 3, up to the 9. And then finally, I'm going to go over 4, up to the 12. Guys, you should be familiar with this from last week. Remember, you had to take your linear equations and you had to set up your table with your x and the y, and you had to put the rule in the middle, the algebraic expression, and you ended up graphing these equations. So you should be very familiar with graphing, and that's all we did here. We just graphed this, but now we're going to determine the slope, okay? So I'm going to zoom in on this graph. or I'm actually just going to scoot this paper over, and let's look at the slope. Now, just a reminder, remember, the slope is the change in y over the change in x, and we'll go ahead and label that here. So we are speaking about y first. That's the first thing we're going to talk about, the y-axis. We're not talking about yards, we're talking about the y-axis. So I'm going to pick 2 points. I'm going to pick these first two, and I'm going to go from here to here. Well, when I go from here to here, how far did that go up? Yes, I know it went up 1 square, but it went up from 3 to 6. So it was an increase, which is positive, of 3. Okay. And next, I want to do the change in x, the horizontal change. So now I'm going to go from this to here. So when I go from here to here, all I did was go from 1 to 2. So that is just an increase in 1. Guys, the change in y, change in x, that is our slope. However, you got to simplify this. 3 over 1. What is 3 divided by 1? 3. Ladies, gentlemen, that is your slope. You just discovered your slope. But again, what does this mean? Yes, I know that I can go up 3 and over 1, but how does it come out to 3 as a slope? Well, when we take 3 divided by 1, our final answer is going to be 3, correct? Well, all this tells us, guys, is the change in y every single time is going to be 3, and the change in x is going to be 1. So the reason I picked this example is very straightforward. Check this out. Every time we change y3, we have to change x1. That is our constant rate of change. So here we go. I'm going to go up 3 on y, 3, over 1 on x. Up 3, over 1. Up 3, over 1. Up 3, over 1. Up 3, over 1. Now again, don't get confused. I know I'm only going up 1 square. Oh, sorry. But I'm going up 3 numbers over here. Up 3, over 1. Up 3, over 1. Up 3, over 1. And I know your head wants to explode because I said that about 1,000,000 times. But however, you see all these little dots? Now let's play connect the dots. Guys, that tells us how steep our line is going to be. We connect that, we have our line. That is the steepness of our line. And there you have it. You have slope. All right, let's attack 2 more examples, and I will be out of your hair for the day. Okay, so we're going to do the same thing we just did. We have our table, and we have a graph here where we're going to graph our ordered pairs. So it says the table shows the number of envelopes stuffed at various times. So we have the time, and we have the envelopes. Now, don't get too confused. Remember, the top of these are always the x-axis, and this is always the y. But again, the labels over here can help you as well. So you can label the x, you can label the y, boom, boom, boom. You are good to go, okay? Now, all right, we got the x, we got the y. Now we're going to label this. Now, to make our ordered pairs, I'm hoping most of you guys can just see the ordered pair. But if not, remember, you take these, and just as a review, x is first, then y. So x would be 5, and y would be 30. That's how we put these together and make our ordered pairs. Are we understanding? I hope. Maybe. So, a little bit. Cool. Here we go. All right. Our first ordered pair is going to be 5, 30. I'm going to go over 5, up 30. Boom. Okay. Next, we have 10, 60. So I'm going to go over 10, up 60. There it is. 15, 90. Go over 15, up 90. And you can start to see like a pattern. Guys, when you have these constant rates of change, it just becomes easy. You know, you can just anticipate where the point's going to be. And again, fellas and ladies, that is what a linear equation looks like. But also, if you have that constant rate of change, you have that slope, and you know the slope, you know what the constant rate of change is, dude, you're going to be golden. You can graph anything anyone throws in front of you. Okay, so we took these and we put them over here, right? All right, now I'm going to scoot this guy over. I'm going to attempt to zoom in. And let me move my coffee, which is very important. One of the main food groups in my life. Let's go ahead and figure out the slope. Now, again, since this is brand new to us, remember the slope is the change in y over the change in x. And again, another way we look at it is rise over run. If you forget that it's y over x, remember, rise is up and down, run is left and right, and y is up and down, x is left and right. So that's probably the greatest way to remember slope. But change in y over change in x. So we're just going to pick out 2 points, any 2 points on here. Okay, so I'm just going to go with what we always do. I'm going to pick out this first point and then the second point. So the change in y, since we're going up from here to here, is I'm going to go from right here to here. So I went, excuse me, my hand's in the way. I went from 30 to 60. So guys, the change in y is going to be 30. I just increased by 30. Do you understand that? I went from 30 to 60. Again, yes, I only went up 2 squares, but I don't care about the squares. I care about the values that are listed over here on the side. So I went from 30 to 60. So I increased in 30. That's my change in y. Now my change in x is going to be from here to here. So from this point to this point. And let me put it in different colors so you can see. I actually don't know how well this blue is going to show up. Okay. So I went from 5 all the way over to 10. So when I change from 5 to 10, what's the difference between 10 and 5? It's only 5. So my change is only plus 5. So guys, I'm on the right track. Here is my change in y over my change in x. But yes, I do need to simplify. And remember, if this is written in fraction form, all this means is you just kind of divide. Not kind of, you do. You simplify. 30 into 5. How many times can 5 go into 30? Think about that. Yeah, this simplifies to 6 over 1, which in the very end means our slope is going to be 6, because we don't typically keep that 1. However, the 1 does help us if we were to graph this. So if our slope was 6 over 1, that means y would go up. That means we would go up 6 over 1, up 6 over 1, up 6 over 1, forever. And then we could connect our beautiful lines, and then we would have a straight line. Now this is the same thing as up 6 over 1, except they increased it. They went up 30 over 5. It's the same thing. Gentlemen, ladies, these are equivalent, okay? These are the same equivalent fractions. This is just kind of like the fraction on steroids, all right? So, I hope you understood that. That's how we found the slope for that guy. And let's move on to the last one. So here we go. This is the final example, but what we are going to do is we have our example here. We're talking about baskets, we're talking about apples, we have our graph. We're going to take this, we're going to graph it over here. But you know what? We're going to take this and graph it over here. Let's do that first. We got our 2 baskets, 10 apples, boom. 4 baskets, 20 apples, Zynga, 630. Where is that? You got old man eyes, can't see. 8 and 40. So guys, we graphed everything. Now, I am sort of confident that you guys can find the slope just by looking at this guy, okay? But I want to show you one little thing before we move forward, something that you are definitely going to be expected to do, and this might be a moment where you do press pause and maybe you write this down somewhere, or maybe you just take a picture in your brain, because you're going to need to know this moving forward. Okay. Instead of finding the slope by using the graph is what we've been doing. Guys, we've been doing the change in y over the change of x, which is the exact same thing as saying rise over run. We will do that, but we're going to try a different way first. Now, did you know that you can actually find the slope just by looking at a table like this. Now remember, the top part of the table is our x and the bottom is our y-axis. Now you can actually determine the slope of a line just by looking at the table, just by looking at a set of ordered pairs, okay? Just like we use these points here, we're going to use these points here. Now, I told you that slope is the change in y over the change in x, correct? Well, we're going to do something a little bit different. This is the first set of ordered pairs, correct? This is the second set of ordered pairs, correct? All right, what we're going to do is we're going to do a little formula that looks like this. We're going to take the second y. Now that is not y squared, not y squared. That stands for the second y minus the first y that's listed over the second x that's listed minus the first x that is listed. Again, this tiny 2 does not mean x squared. That 2 just represents the second x that's listed. So these were the second ordered pairs. These are the first set of ordered pairs, okay? So what we're going to do is we're going to take, what is the second y that's listed? That is the first one. That is the second one. So I'm going to take the second y minus, what is the first y? 10. Just like that. Okay? We took the second y, the second one, minus the first one, minus 10. And then now we're going to take the second x. That is the first x. This is the second. We're going to take the second x minus the first x, which is 2. And guys, now we are going to find the answers to this. 20 minus 10 is 10. What is 4 minus 2? 2. Guys, now I need to simplify this. 10 over 2 simplifies to 5 over 1. This is our slope. Now we say slope equals 5, or again 5 over 1. The change in y is you go up 5, and the change in x is over 1, up 5 over 1, up 5 over 1, up 5 over 1. We just did all that by using this table in this crazy little formula right here, okay? I'm just trying to show you multiple ways to determine the slope of a line. Now for some of you guys, your head might have just exploded as we went over this. Now this is not going away. You will see this in the future, but I just wanted to show you this, okay? Now let's look at the graph. If I do the same thing, I'm going to find 2 points, okay? I'm going to go, my change in y, I'm going to go up from here to here. So what did that change? It went from 10 to 20. The change was 10, right? Now I'm going to find the change in x. I went from here to here. The change was 2 to 4. 2 to 4. So the change was 2. Don't those look similar? Now I'm going to simplify. Guys, I get the exact same thing. Boom. Guys, we just determined the slope. Okay, well, that was it. I know that was a lengthy video, had a lot of information, but guys, I just want you to really understand this concept. Slope can be difficult for some kids. I told you guys at the beginning of the year, you guys are 6th graders and you're rocking it. I told you I ran into a handful of freshman algebra teachers where the freshmen in high school were having difficulty determining the slope of a line. I truly feel you guys can do this. You just need to focus, check out the video. but due to the length of the video, I know it's a long video, I know it's crazy, I'm only going to give you one assignment this week. So you're going to have this video, and then you're going to have one assignment that you do need to turn in. It has 6 problems, that's it. If you have any questions, I will be in touch. I'm going to post a link on our Google Classroom. We're going to have a Google Hangout soon, so you can ask me any and all questions you have about slope. But please do me a solid and watch the entire YouTube video. Maybe break it up, do what you got to do, but remember, I'm here to help, and I just want you to learn this concept because it is not going away. Stay happy, stay healthy, and please stay safe, and hopefully we'll see each other soon. Take care.